Hello students. So in my last lecture I have told you about the mapping, cache mapping, and today I will discuss with you about the mapping structures. So there are three types of the mapping, and whenever we are going to put some data in the cache memory, as we have already discussed in my last lecture, that there is a mapping function. So here we have already discussed about the cache mapping. Yes, so there are three types of the mapping: direct mapping, associative mapping, set associative mapping. And another thing we have already discussed with you, that we have a cache memory, and on this cache the data need to be transferred from the main memory. Okay, so now let's discuss that how it happens. So whenever we are going to feed my cache with the data available in the main memory, then these type of techniques are known as mapping techniques. Okay, so there are three type of the techniques. One is your direct mapping, fully associative mapping, and another is set associative mapping. So now let's discuss about the direct mapping. So what is direct mapping? So suppose we have a cache of L0 of 4 lines. 4 lines means it has 4 lines of the main memory. So it has L0, L1, L2 and L3. So another thing, we have main memory, right? This is my main memory, this is my cache, and this is my main memory. So in that case you can see that there are some blocks. So my main memory, you can say that my main memory can be divided into blocks, and my cache memory is divided into number of lines. Fine. So now my number of lines are the number of words in a line are equal to number of words in a block. Okay, so my size of blocks and size of line is equal. So there is no any difference in line of size and line of block. So for example, if there is W0, W1, W2, W3, so similarly there may be 4 blocks of the 4 blocks can be maybe come in that case. Okay, so there will be also some W0, W1, W2, W3, likewise this. Understand? So my line size is equal to block size, means number of bytes in line 0 is 4, so my number of blocks in block 0 is also 4. Okay, so there is no any difference. Yes, there is a difference in capacity of the memory. So cache capacity is definitely lesser than that of the main memory. Okay, so here you can also see that there are 4 lines of the cache, and each line can occupy 4 words. And here you can see there are 32 blocks of lines, blocks of data, and each block of the data can contain 4 bytes of the 4 words or 4 bytes of the data, right? So whenever we say that it is a direct mapping, whenever we say that if it is a direct mapping, so we follow a formula, and it is k mod n. Okay, where k is your block number, this B0, B1, B2, B3, B4 and so on. So that is my block number, so that is my k, and n is my line number. So I can show you, we can say that at particular line some particular blocks can come. Otherwise it may happen that if there is a line, the line is empty, and the particular block may become over there, then line may get empty if it is not available. Fine, I will show you how. So in that given case, in B0 to B31 there are 4 blocks. These are the blocks of the main memory, and n are the number of the lines, which are 4 in cache. Okay, so now see, as I told you that there is a k mod n. So if block number is 0 and line number is 4, so which type of the data may come over here? In that case, in line number 0, so line number of lines are 4, so number of lines are 4, so block number 0, what about the block number 0? So it may come in line 0, so that is my line number, I have just told you about the formula. In that case, k mod n, k is my block number, n is total number of lines. So here I am saying you that total number of lines are 4, and this is my block number. So my block number 0 can come in only line number 0. So B0 may come here, and so my block number 1 can come in only in line number 1. So you can see line number 1 can contain only block number 1. So block number 1 means the data of the block 1, means line 1 can contain, line 1 may contain W4, W5, W6, W7, any of this data, right? So all these data bytes can come in line number 1. So similarly we can see that line number 2 contain block number 2, line number 3 contain block number 3. Similarly line number 4 contain, line number 0 contain block number 4, block number 5 contained by line number 1. So in that case you can see that there are number of the blocks, and all the number, any of the particular block has a particular line number. So that is not possible that B0 can be saved in L1, that is not possible that a B3 can saved in L1. No, that is only possible which is defined by this formula only. Okay, so using this formula what we have decided that B0 may come here, B4 may come here, B8 may come here, B12 may come here. So any of that block may reside in L0. Any of B1, B5, B9, B30 or up to 29 may come in that block, in that line number. Any of these block B2, B6 and so on may come in L2. Any of B3, B7, B11 may come in L3. So that's how we define the blocks of the main memory in our cache using direct mapping method. Okay, so now here I have also written that L0 may contain any of the block of B0, B4, B8, B12 and so on. So now see how the address is generated by the CPU for main memory in the given system. So in that case, whatever we have taken here, in that case we generally have total number of words 128. So you can see that here W0 to B31. So you can see here, so there is W0 to B31, W127. So there are total number of words 128, right? So B0 to B31. So number of total blocks are B0 to B31, right? So now let's see another thing, that total number of words is 128, total number of blocks are 32. Why? Because in a single block there are 4 words. So I have to divide this number of words by number of blocks. Okay, so total number of blocks is total number of words are 128, and in a single line 4 words may come. So total 32 blocks I can achieve from here. Okay, so address of CPU contains, for a main memory what will happen, it will provide you a 5-bit of the block number. So definitely if it is a 32-bit, so only 5 bits are needed and 2 blocks are for the offset, right? So for example, block number is there for the 32 bits. So because there are 32 blocks, you can see there are B0 to B31, these are 32 blocks. And now you can see to define these 32 blocks I need 5 bits. So 5 bits, in the 5 bits I can access all these 32 blocks, and in 2 bits blocks, so my block offset is fixed, right? Block offset is of 2 bits, so only 4 words are there. So 0001 1011, right? So that's how I can define my 4 words. So any of the word I can access. So if my CPU says W2 from line 0, so it will provide you 000010, right? Now see the example. So for example, it is 0001010. So first 5 bits are my block number. So first 5 bits are 010. So it is B2, right? And which number of the block? So next two bits are my offset. So it is my index, offset or index. So 10. So that is a second word. So 0 1 2, that second word I have put a crosshair, that is demanded by the CPU, right? Now let's see about the cache memory, how the cache memory is addressed by the CPU. If 2 bits are for the offset, definitely, because number of the blocks, number of the words in a line are same as number of words in a block. So W0, W1, W2, W3, right? So 4 blocks, 4 words are there and 4 words are there, so same number of the blocks are there, right? So 2 bits are for the offset, so W0, W1, W2, W3. So which number of the word I need to be assessed are defined by 2 bits only. So this is my word offset. Next is my 2 bits are for line number. So there are 4 lines, so 0 0 0 1 1 0 1 1, so only 2 bits are required, so I put here 2 bits. So rest of the bits are my tag lines, tag number. So 3 bits are for my tag number, so 0 0 0 2 1 1 1. So 3 bits are for my there. So there are 8 of the tag numbers I can assess. So 3 bits are for the tag numbers, indicate that only 8 words may possible in one line of the cache word memory following K-mod-N formula. Okay, now see, if my CPU generates 001 001 00 sorry 001 001 0, this address is represented by the CPU. So now first 3 bits are for tag lines, so 001. Next is 00 means line number 0, so 00 means line number 0, and 10 is means word number 2, so word number 2 will be assessed. Okay, so word number 2. Now how it will be interpreted? So 1 2 4 8 16, right? 16 plus 2 18, so 18 number word must be assessed by the CPU. Okay, so now let's see, where does the word 18 exist? So word 0, word 1, word 2, word 3, word 4, word 5, word 6, word 7, and so on, and word 18 exists here. I am just zooming it. Now you can see here that word number 18 is here in in block number 4. So where does block number 4 can exist? So you know that it can exist in line number 0, right? I have just told you that block number 4 can exist in line number 0, B0, B4. So this word can be exist here in line number 0. So now you can see, so my word number 2 must be there and line number 0. So word number 18 is required by the CPU, and this will exist in line number 0, which contains block number 4, right? So block 4 is contained by the cache, and this is line number, and this is in line number 0. Okay, so this is my direct mapping. So that's how we just have a direct mapping. So you should work on it, you should try it, you should practice this using some more examples. So you may get the examples on internet, or I may provide you some more examples on that case, and you should learn these things. And in my next lecture I will tell you about fully associative mapping and set associative mapping. Thank you.